So welcome students. So last class we have seen about weldability of austenitic stainless steel. So today, this lecture will cover the weldability of aluminium alloy. So the weldability of aluminium alloy, first we should know about what is the basic mechanical or physical properties of aluminium. Then only we can able to know what is a welding and also what is a weldability. Then what are the problems which will be arised when we go for welding aluminium alloy. So first we should know about the aluminium. So aluminium melting point, you should aluminium melting point 662 degrees centigrade. And what are all the basic properties of aluminium? The aluminium which is having high thermal expansion. Second one, high thermal conductivity. Solidification temperature range, that is the meaning of solidification temperature range is the aluminium liquid state metal is transformed into solid state. The time taken the liquid phase material to solid phase material. So what is the time taken? So that is called solidification time range, solidification temperature range. So the thermal conductivity also higher, thermal expansion also higher. And so you can have some idea. If thermal conductivity is higher, what happens when you go for welding the aluminium alloy? The metal, the whatever heat which we are going to give is getting dissipated, and we cannot able to attain the localized heat or high power density heat. We cannot able to attain high power density heat at the localized welded area. So we cannot able to attain a heat to melt the liquid metal at a faster rate and solidify the metal at the welded area. So we need to give more heat to the aluminium alloy. It will because of thermal conductivity, it leads to the heat affected zone area will be getting increased. So because we are giving more heat input to the aluminium alloy, so because of that, what happened in the nearer to the fusion boundary area, the heat affected zone will be getting increased. The thickness, the zone level will be getting increased. The heat affected zone getting increased due to the high thermal conductivity of the aluminium alloy. That is some kind of drawbacks in welding aluminium alloy. So we can see remaining things. So what are the problems? First one, residual stress and solidification cracking tendency, partial melting zone cracking tendency, and distortion. These are all the problems which are arised when we go for welding aluminium alloy. As I said, high thermal conductivity means high dissipation of heat, so it leads to wider heat affected zone. So due to the high thermal conductivity, we need to give more heat into the aluminium alloy, so we need to spend more energy, and also we need to give more heat input. It leads to larger heat affected zone, leads to defect, and the solidification temperature range so much wider, so that will increase the cracking tendency. Solidification temperature range will also increase the cracking tendency because the liquid phase material is transformed to solidified phase. So there is a time gap. So due to that, there will be a formation of porosity. The gas can be easily absorbed by the liquid metal. So these are all the problems. So there will be a formation of porosity. These are all, and also we are having partial melting zone cracking. This is also the subsequent chapter we are going to see. So what then? Next one, mechanical property, percentage of elongation. The percentage of elongation means it's about strength. So the aluminum material is having yield strength. If you consider the yield strength is somewhat less. So the residual stress will be somewhat lower compared to other material. So this is good thing for welding aluminum alloy. Second thing, so we are going to see about what are all the problems when we are going for welding aluminum alloy. Aluminum alloy is highly reactive material. What happens? The aluminum, when we are going for welding aluminum material, the aluminum liquid state material which can easily react with the oxygen and convert into aluminum oxide. That aluminum oxide is highly brittle material and also it's high melting point material. It even 2000 degrees centigrade it is getting melted. So due to the formation of aluminum oxide in the fusion boundary area and fusion zone, completely the aluminum oxide formation, which will deteriorates the mechanical property of the aluminum material. That is a major problem. So this is what given here. The alumina is low melting. Alumina is low melting around 6. Aluminium is 662 degrees centigrade. But refractory alumina is melted high temperature 2000 degrees centigrade. It's not alumina, it's aluminium. Refractory aluminum means it's alumina, Al2O3, melts at high temperature of 2000 degrees centigrade. So the molten bit of aluminum in fusion boundary react with oxygen. So if the alumina induce formation of white, they reduce strength and ductility of the aluminum material. That is a drawback. So, and also what are the other issues in the things? As I already know, high thermal conductivity and high solidification range, affinity with atmospheric gases, and also expansion coefficient, high expansion coefficient. These are the problems. So due to that, we are not able to select gas welding, shielded metal arc welding for welding aluminum alloy, because gas welding, shielded metal arc welding will not have any kind of argon or helium inert gas atmosphere. So when you weld the aluminum alloy material with the gas or arc welding, the oxygen can easily react with the aluminum and there will be a formation of aluminum oxide. So in order to avoid these things, we should go for tungsten metal arc welding, gas metal arc welding, tungsten arc welding, plasma arc welding for aluminum alloy. So we need to weld aluminum material with inert gas atmosphere. So this is the best suitable method, and also nowadays we go for friction stir welding process for welding aluminum alloy. Okay, next. So what are all the various technologies? Technology issues in welding aluminum alloy. The aluminum have a tendency to absorb hydrogen gases in the atmosphere and in the melting when it is getting completely in liquid state. So there will be a formation of pores inside the aluminum when it is going for when it is in the liquid state. When it is after solidification, the gases which are inside the liquid metal which will be present. So there will be a lot of porosity, and also we are having cracks and liquid state, partial melting zone. These are all the defects in the welding aluminum material. Next, softening of HIZ, heat affected zone. So we can see one by one. So in order to avoid or overcome these things, in order to avoid solidification temperature range for aluminium alloy during welding process is here. So what we can do? So we need to select appropriate filler material to reduce the solidification temperature range, so that we can able to reduce the solidification temperature range to reduce the defect. That is what it is given here. So when this graph tells about, this is a iron carbon, like iron carbon equilibrium diagram is the aluminium alloy based equilibrium diagram, where we are having liquid, the liquid region is a solid region. This is the line where the liquid state to solid state, in this 8 to 10% of B alloy composition, we are having longer length. You can see liquid to solid. So we need to shift the line to this position. The percentage of carbon level will be increased. So in that region we can have very limited liquid to solid transformation. So we need to select the filler material accordingly. So the filler material should be selected so that we can reduce the solidification range, so that the absorption of hydrogen gases can be avoided. So when we go for large solidification range, the gas and the liquid metal has maximum able to occur or absorb more hydrogen gases, because it has more time. Here we are having less time, not able to absorb. So immediately the solidification time range can be, solidification temperature range can be little. So this use for suitable filler material to reduce solidification temperature range. So this is one of the best way to reduce defect in case of solidification temperature range. Next we are telling about partial melting zone. What is mean by partial melting zone? This is the heat affected zone area. In the heat affected zone area, this boundary line is a fusion boundary. The nearby line, which we are calling it as fusion, and this one is heat affected zone. In between, what happened? The metal which is in the state of two phases, liquid plus solid. So the liquid metal and solid metal will be present here. This area complete solid, but here we are having complete liquid metal. So the liquid solid metal is after welding, what happened? It is getting solidified. So the liquid solid material also getting solidified progressively. In that situation, what happens? Some liquid metal will not get solidified, or so there will be a contradiction. So due to that, there will be a crack formation will be occurred in the that is called, we are calling it as, that is what we are calling it as partial melting zone. So we need to, how can we avoid this thing? We need to reduce net heat input to reduce liquid cracking in heat affected zone. So heat affected zone should be reduced. How can we reduce the heat affected zone? We need to reduce the heat input. We should concentrate. We need to give high power density welding process to reduce the heat input, so that the welded localized welding can be happen in the welded alloy. So cracking due to residual stress only affect to reduce. So next one, the residual stress. What is mean the residual stress? There will be a contract. When the metal is getting heated, it is expand. When it is cooled, it will get contract. Due to that, there will be a formation of residual stress. That also we can able to reduce by selecting appropriate filler material, and we should reduce the heat input. So filler material should be selected in such a way that the filler material is in liquid state, and before that the partial melting zone solidifies, so the solid region can sustain this stress. So welding region solidifies after solidification of the partial melting zone. Next, okay. Next one, this area is a softening area. That is a third defect. What is mean by softening? This is a very important question. Actually, we are giving heat to the interface area where we are going to join the material. So the metal is completely melted. The heat will be dissipated. The nearby zone, so heat affected zone, where the metal is not completely melted, but what happened, this area is getting heated. Due to the heat, the internal microstructure, there will be a recrystallization, recovery, growth. This is a problem. So due to the recrystallization, recovery and growth, due to that particular material is getting softened, because aluminium alloys are manufactured with some kind of specific application by hot rolling process and work hardening process, and also precipitation strengthening process. So the basic raw material is getting strengthened by work hardening process. Work hardening means the grain size of the material will be very tiny, very small microstructure, very small grain structure. So when you weld the material, what happened? The heat affected zone will be getting affected. That particular heat affected zone material is again going for grain growth, recrystallization and recovery. So the original property, original grain structure is getting collapsed. That is called softening effect. So this is another problem. So we need to reduce the heat affected zone, so by way of using high power density welding process. So this is the one way we can able to reduce the heat affected zone. So this is what is mentioned here, softening of heat affected zone. So the post weld heat treatment is not possible for work hardening. Post weld heat treatment can be possible only for precipitation strengthening alloy, aluminium alloy. So the post weld heat treatment used to actually post weld heat treatment used to give precipitation strengthening process. It is one of the precipitation strengthening process, not the work hardening process. So work hardened material cannot be used for post weld heat treatment process. That is another problem. So we can able to have post weld heat treatment for the aluminium alloy, which is actually having precipitation strengthening alloy. Next step. So what are all the things? So whatever we have discussed is here. So aluminium, we are having porosity. So gas porosity, how it is happened due to the solidification temperature range. So the gases will be getting absorbed. So the gases will be here. Gases have limited solubility. So the solidification rate is high. Gases is interrupt. It will be interrupt inside the solid metal. So it is having problem. And also the hydrogen gas. Hydrogen gas is when is hitting melted region. Here we are having completely melted area. So there will be a hydrogen gas will be absorbed more. So and also it's getting rejected when it is getting solidified. So this is another problem, solidification, cracking or gas porosity. Next is shrinkage porosity. Shrinkage porosity means we are having two different kind of porosity. One is due to the absorption of gases. The next one is due to the limited fluidity of the liquid metal. Limited fluidity means that when the transformation of liquid state to solid state, the coarsening effect of the grain structure. So when it is coarsening effect, the grains will be formed due to the dendrite, that is called the dendrites. We are calling it as dendrites. The dendrites are formed inside, in between the dendrites there will be a liquid metal will be present. So that is called shrinkage porosity. So when it is getting solidified, what happen, these liquid metal will create some kind of porous inside the microstructure. So that is called shrinkage porosity. So in order to avoid these things, we need to using degassing we have to give some chemical compounds to increase the fluidity of the aluminum material. So proper cleaning of base metal is also used to reduce the shrinkage porosity. So softening of the heat affected zone, as I have told, this is a liquid metal area, this is a partial melting zone area, heat affected zone, or heat affected zone, partial melting zone, and the remaining area is a softening effect. The softening effect due to the recovery, recrystallization, grain growth. So metal loses its original property. The aluminium material loses its original property. So these are all the problems in the aluminium alloy. This is what we have explained in the weldability of aluminium. So over. So my next lecture we can see the remaining portions in unit 5. So the weldability of copper will be there. So more or less, if time permits, we will explain. Thank you for listening.